An ionic bond is a little bit like a polar bond and a little bit like a hydrogen bond. An ionic bond results from a two-step process where in the first step, one atom pulls an electron completely away from another. And in the second step, the resulting positive and negative charge produces an attraction between those two atoms. So during an ionic bond, the first thing that happens is that we make a pair of ions. An ion is an atom or a molecule that has gained or lost at least one electron. So we're mostly going to focus on atoms that are losing electrons in this video, but keep in mind that a whole molecule can lose an electron as well, and that whole molecule can become charged. So what I mean is, for example, chlorine can gain an electron and have a negative charge. Conversely, a sodium ion can lose an electron and gain a positive charge. We could also have an ammonia ion where this has lost an electron and the whole atom has become positively charged. Sorry, the whole molecule. This is a whole molecule. So when an ion gains or loses an electron, it becomes either a cation or an anion. A cation is an ion that has a positive charge. Now, this positive charge comes from a lost electron. In other words, an electron has been pulled completely off of the atom, removed from its valence shell, and transferred to another. Because electrons are negatively charged, when negativity is lost, it becomes more positive. So the loss of one electron produces a +1 charge. The loss of two electrons is going to produce a +2 charge. Conversely, an anion is an ion that has a negative charge. This happens when it has gained an electron. This is because electrons are negatively charged, and so if you bring in more negativity, they are going to become negative. Now, just like your cations, if you gain one electron, you become a -1 charge. If you gain two electrons, you gain a -2 charge. So keep in mind that electrons are negative. So if you gain an electron, you become more negative. Now, I like to use kittens to help me remember which one is a cation and which one is an anion. So we've got this adorable little kitten up here on the side. The way that I remember this is that cats have paws. And so this cute little kitten is going to help us remember that cations have a positive charge. Anions then have a negative charge. So our first step is the loss of one electron from one atom to another atom. Now that produces a negative charge on one atom and a positive charge on the other. Now this is slightly different from a polar bond or a hydrogen bond where we get a region that is slightly more charged than the other. The entire atom becomes positively or negatively charged. But the same thing happens as happens with polar bonds. When you have that difference in charge, they're going to attract one another. And this attraction is called an electrostatic attraction, an attraction between two oppositely charged particles. So this could be between two water molecules producing a hydrogen bond. It could be between two ions that are fully positive and fully negative. Now, our ionic bonds are the result of extremely electronegative atoms. These atoms are so electronegative that they don't just pull an electron towards themselves, they completely strip it, pull it towards themselves. And then that electron becomes part of that atom. It's not shared, it's fully part of it. Ionic compounds are more commonly called salts. So you are familiar with these. You've probably heard of these examples here. Sodium chloride, that's table salt. So if you have a little container of salt and pepper on your dining room table, that's what this is, sodium chloride. Calcium chloride and potassium chloride are other common examples. Chlorine molecules are really common, or chlorine atoms, I should say, are really commonly salts, and that's because chlorine really likes to gain an electron. Now think about property of salts. You put these on your food, and you also can put them in something like a soup. You can dissolve salts in water. So keep that in mind. That's going to be really important in just a minute. So I like to think of ionic bonds as a really bad relationship. This is an atomic relationship where one side of the relationship completely takes something away from the other and doesn't give it back. So that's why I like to think of it as sort of the bad relationship. You've got one side, one atom that has fully taken something from the other and doesn't want to share it. And then you've got the other one who's lost something that's just sort of hanging around, won't let them go. So first we have the loss of the electrons produce the ions. Second, we have the formation of an ionic bond. Now the ionic bond forms when you have that loss of electron that produces a positively charged molecule and a negatively charged molecule or atom. And then because opposites attract, the positive atom is going to be attracted to the negative atom. So here we've got sodium chloride as our example. We've got the valence shell of our chlorine atom here. You'll notice that it has one unpaired valence electron. That electron really, really wants a partner. Chlorine is very electronegative, and so it's going to pull an electron from another atom. In this case, that atom is sodium. Sodium has a single valence electron in its valence shell. So because chlorine is electronegative, sodium wants to be more stable. Chlorine wants to fill its valence shell. It's going to pull an electron from that sodium ion and use it to fill its valence shell. When that happens, it gains an electron, so it goes from 17 electrons to 18, which means the overall molecule is going to have a -1 charge. So we call the chloride ion Cl-, indicating that it has a -1 charge. Sodium has gone from 11 electrons down to 10, has lost an electron, which means sodium now has a positive charge. That's positive sodium, negative chlorine are going to be attracted to one another. Now, salts are kind of cool in that when they are attracted to one another, that electron is anywhere around the chlorine, and so there's a sort of what's the word I'm looking for? Symmetrical distribution of that negative charge. And so your sodium are going to be evenly spaced around your chlorine, and this is going to give a crystal shape. So if you look at sodium chloride under a microscope, or even if you look, you can see them when you pour them out on your plate, they produce these little tiny squares. And that's because they pack really neatly because of their even charges and their attraction to one another into these nice little lattice structures. So if we think of these in terms of electronegativity, our nonpolar covalent, our polar covalent, and our ions all have different levels of electronegativity. Remember that our non-polar covalent bonds are between two atoms that have essentially similar electronegativity, which means that electrons are going to be found evenly distributed across two atoms. There's going to be no charge around those nonpolar molecules. Now, this is going to be really important when we start talking about our biological molecules, because without that charge, there's going to be no interaction with our charged molecules, such as water. However, with the polar covalent and the ionic bonds, we have those charged regions. In our polar covalent bonds, we get region of partial charge. So one region is more strongly charged than the other, but the whole molecule maintains all of its electrons. Our example here is water and many of our other biological molecules, such as carbohydrates, proteins, and nucleic acids. Our ions are formed because we have atoms that are so electronegative that they completely strip an electron from another atom. What that results in is an atom that has fully gained a charge, one that has fully lost a charge. So our polar molecules and our ionic molecules are going to interact well with each other and with water. This interaction between our ions, our polar molecules, and water are really important for living cells. And that's because our living cells are approximately 75% or more of water. So within the contents of our cell, we have this fluid called the cytoplasm. And the cytoplasm is basically water and then some other important molecules that are dissolved within it. And so any molecule that you find within a cell is going to need to interact well with water. Inside those cells, we have a solution. A solution is basically a solid dissolved in a liquid. So we call those solids the solutes, and they are the content that is dissolved. So water is going to interact with positive and negative, interrupt the bonds between the individual atoms or molecules, say between the sodium and the chloride, and separate it to dissolve. So think about salt dissolving in soup or sugar dissolving in your coffee or your tea. The solvent is the liquid that does the dissolving. Now, any liquid and any solid could be the solute and the solvent, but in a cell, water is going to be our solvent. And when water is our solvent, we call that an aqueous, like aqua, an aqueous solution. So the insides of our cells are filled with this aqueous solution that has dissolved things like sodium and potassium and sugars and whatnot inside of our cell. So this is a really important property, that our ions and our polar molecules dissolve well in water. We call this property hydrophilic. It means that ions and polar molecules are attracted to and will interact with water. Our non-polar molecules don't like to interact well with water, and we call those ones hydrophobic. These ones are not going to interact with water. These are going to be our nonpolar molecules, and the most common biological molecule are the lipids, which contain our fats. Now, you probably already know that fats do not interact well with water, and that's because they are made up of nonpolar bonds.